Welcome to my primary 4 students in the second part of Concept 4, Energy and Collisions. In our previous lesson, we wondered about what happened to objects during collisions, and we started to explore the cause and the effect of collision and energy transfer. And we learned about collision between two moving objects, as in the cricket bat and the ball, and a collision between a moving object with a stable object, as in the wrecking ball. And we studied how the speed and mass can affect the collision and the amount of energy it has, and how we use these facts and information to invent safety features that protect drivers and passengers during a collision, as seat belts and airbags. So let's continue analyzing different situations of collisions in our second lesson. We learned before that collision is when two objects hitting or crashes one another that causes energy transfer between objects and energy transformed from one form to another. But also collision could happen between more than two objects. So what happened to the objects before and after collision? Our first example here is a simple one that may happen in our daily life, like when you bump into someone while you are running or accidentally hit something so it fall down. So for example, if you are running down the street without looking in front of you, a traffic sign post in this situation, you may stop moving and you may bounce or fall, and the sign itself might wobble or vibrate. That means that you transfer your kinetic energy to the sign. Let's see together this example. As you can see, Tom hit a shovel and a rake and spade. So he transferred its kinetic energy to the rake, spade and shovel, where the shovel vibrates and wobbles. And also, Tom stopped moving when he hit the shovel and the rake and the spade. So the kinetic energy transfers from body's Tom to the shovel that leads to the vibration and wobble of the shovel. Also, a part of his kinetic energy changes into sound energy when we hear the collision of Tom and the shovel and rake and spade. Here in the first situation, the dog is running and hits the sign, so it transfers its kinetic energy to the sign that make it wobble. Also, it stopped moving. The dog stopped moving. That means that it no longer have kinetic energy, but it has potential energy stored in his body. If the dog bounces back, that means that it has kinetic energy. In the second example, it's the same situation, but the boy here hit the sign while he were walking, not running. And walking means that the boy have low speed, That means that his kinetic energy is low, so if he will hit the sign, he will not have that great impact on it to make it vibrate or wobble. So whenever the speed increases of an object, the kinetic energy increases, and when it collides with another object, it will be able to transfer a great amount of its kinetic energy. So the fastest object transfer a great parts of their kinetic energy, unlike the slowest objects. If we apply the same ideas on the cars which move fast on the road, we will find that whenever a car moves with a high speed, it will be able to transfer a great amount of its kinetic energy to the object that it crashes into, and will cause more damage. The transfer of energy will appear in different forms, like sound energy, which we will hear in the collision sound, and maybe it will appear in the form of light and thermal energy generated from the friction force between the colliding objects. So the fast object has more or extra energy, while the slow moving object has less energy. When this object hits another object, it exerts more force. But a slow moving object, when this object hits another object, it exerts less force. The force in the fast moving object will cause a big damage to the object that cannot be repaired. But in slow moving objects, this force causes less damage to this object than the fast moving object. That's why driving fast is very dangerous, where if a car increases its speed, its kinetic energy increases, that result in exerting a large force during an accident. So as we can see in this example, a car speeding up on the road has more energy, crashes into an object. It transfers a big part of kinetic energy, causes more damage and very big damage that cannot be repaired. Also here in this example, a car with a big mass and with high speed will be able to transfer a great amount of its kinetic energy to the cars that it crashes into, and also cause more damage and transfer a big amount of its kinetic energy, and this transfer appear in different forms, like sound energy and thermal energy and light energy, generated from the friction force between the colliding objects. So what happens if two speeding cars traveling opposing each other in direction collided? Two objects moving with high speed have high kinetic energy opposing each other in direction. The increase of the speed will increase the amount of energy transferred between objects, which means that the sound of collision will be too loud and the generated thermal energy will be great. Each car can push the other one for a distance, and the damage may be severe for both of them and will be almost in the front of the car. The damage may differ with different situations. If two cars move at different speeds in the same direction, collide with each other, the force exerted in the accident depends on the speed of both cars. This leads to damage would be less severe because they move in the same direction. Speed and collisions. As the force and speed of a moving object increase, the amount of its kinetic energy increases during collision. As the kinetic energy of a moving object increases during collision, more damage will happen to this object. In this experiment, we will try to apply different forces to a Play-Doh and see how can the force affect its kinetic energy. So first, we will try to drop the Play-Doh without applying any force. We realize that there was a very small impact on the shape of the dough. And then we will apply a gentle force on the Play-Doh, and as you can see, the Play-Doh is getting more flat. And finally, we will throw the dough, but with a hard force. As you can see, the hard force affects the shape so much. Based on this experiment, we can conclude that the relation between the force, speed, and kinetic energy is a direct relation. It means that by increasing the force, the speed increases and the kinetic energy increases. So now we know how force can affect kinetic energy that transfer during a collision. The more the force increases, the faster it goes, and this causes an increase in the object kinetic energy. So there is a greater probability of greater damage when the fast moving object collides with something. That's why the last time we throw the ball harder, it affects its shape so much. There is a very important factor that we need to analyze its effect during the object collision, which is the mass. The effect of mass on collisions. The relation between the mass of objects and their kinetic energy. Imagine that a boy running accidentally hits you and you fall down. Now try to imagine the same situation, but instead of the small boy, a small cat running hits you. Will you fall down and have the same impact? Of course not, because its collision impact will be weak, meaning that the cat's kinetic energy is not great enough to make you move. And like the wrecking ball, which was made of steel, or the train we saw which could move a car to a great distance, smashing a big part of it without making any smash or damage to the train. The difference in these situations was the object mass. That's why we will start analyzing and collect evidence on how the object mass affects the amount of kinetic energy during a collision. The greater the mass of a moving object, the greater its kinetic energy. Large trucks has big mass. Due to their bigger mass, need an engine that is bigger than the car engine. And we learned before that cars powered by gasoline, that it has to burn to produce energy to move the car. And the greater the mass of a vehicle is, the more fuel it consumes, and the more kinetic energy it gains. And that reminds us with the relation between speed and kinetic energy. So the question is, what if two objects are equal in speed but different in mass? Which vehicle has more kinetic energy? The important factor here is mass. The truck has more kinetic energy because of its big mass, and bigger the mass of an object, the more kinetic energy it has when moving at a specific speed. This analysis leads us to an important result, which is that object with big mass causes huge damages when it collides something. If we compare it to a vehicle that has less mass and equal in speed, and if these objects travel faster, they will cause more damage because their kinetic energy is gonna be doubled. We collected evidence on the effect of force and speed and energy. We also started to analyze the effect of other factors, which is mass, and understand its relation between the kinetic energy of an object and its effect on collision. The truck that its mass is 1 ton has half the kinetic energy than another truck its mass 2 tons when they both move at the same speed. It's because if the mass of an object increases, its kinetic energy at the same speed also increases. The effect of mass on collisions. A large mass vehicle causes more damage when it hits something than a small mass vehicle traveling at the same speed. For example, a bicycle moves at a certain speed, hits a person. The bicycle will cause some injuries to this person, but he will survive. A car moves at the same speed, hits a person, the life of this person may be in danger. Let's study the pros and cons of the solar vehicles, or the advantages or disadvantages of using solar vehicles. The advantages is that they don't need gasoline to move. Also, they don't need to charge their batteries using electricity. And of course, they don't cause air pollution or climate change. But also the cons that they are slow. They are slower than the cars, the gasoline cars and the electric cars, because the amount of energy that we can get from the sun is not as great as the amount of energy that we can get from gasoline or electric batteries. That's why mechanical engineers think how to make it faster. So they try to reduce its weight by removing the speedometer, but also that make it difficult to measure the speed. But you can help mechanical engineer to measure the speed, as we learned before. So we can measure the speed by measure the distance of the solar vehicle that travel over the time taken by the car to travel that distance. So by measuring the distance and calculate the time, we can know the speed. Let's review the most important points of this lesson. Speed is one of the factors we need to consider. We explained some real situations by showing before and after collision, and the main transfer of the kinetic energy between objects. And we analyze some information about the relation between objects speed, the amount of energy which can be transferred during collision. And we explain the scientific term of collision. We have learned that if a fast object collided with another object, it will be able to move it to a certain distance, as it moves part of its kinetic energy to the other object it hits. That's why fast objects tends to make a great damages, unlike if the object speed was low. Now, a question. Is the speed the only factor that affects collision? Let's investigate this point next lesson. And for now, study well and see you next time. We examine the effect of an inclined slope or ramp on the speed and the energy of moving objects. We measured the impact of speed on collision by changing the height of the slope. And the more the speed increases, the more the kinetic energy increases, the more the time decreases. It means fast objects has more speed and more kinetic energy and take less time. So the more inclined slope increases, the more the speed increases, the more the kinetic energy increases, the more the time taken decreases. So the speed of the moving object on a ramp increases by increasing its mass. By increasing the mass of an object that moves down a ramp, the kinetic energy of this object increases. Note, the speed and kinetic energy of a moving object on a ramp can be increased by increasing the angle of the ramp, of the slope, and increasing the mass of the object. So, as we can see here, moving balls, the one that travels first has the greater mass and the greater speed. So again, by increasing the mass, the force increases, the speed increases, the kinetic energy increases, and the damage increases. What happens to objects when they collide with another object? We have learned that the energy transfer between objects during the collision and the greater speed and mass of a moving object, the greater kinetic energy this object has during a collision. When an object collides with another one, it transfers all its kinetic energy or just some amount of it. Does the energy disappear in a collision? Let's see together a simple device, we call it Newton's cradle, that has a special way of moving. As when we pull the first ball and we let it go, the balls start moving back and forth. Why the balls in the middle didn't move? Do the balls will keep moving or they will stop? When the first ball at one end released, the balls in the middle hardly move, but the outer last ball is at the opposite end is pushed away from the frame. It's a good demonstration of energy transfer. The ball that you pull has potential energy, which converts into kinetic energy and causes it to collide with the next ball. The energy is then transferred down the line. It's only when the energy is transferred to the outermost last ball, to the opposite end, that there is a significant movement, because it doesn't have another ball to transfer its energy to. When we pull back the first ball, it means that we do work. So it stores potential energy. And once we let it go, the energy converts from potential energy into kinetic energy. Then the ball transfers its kinetic energy to the second ball. Then the second ball keeps transferring till it reaches the last ball. Then the last ball didn't find any object to hit, so its motion will be free and rises up, storing the kinetic energy in the form of potential energy as it's going up. Then again it falls down, transforming the potential energy into kinetic energy, repeating the same sequence again. What if we pull two of the balls, and what's going to happen? Why is the energy here able to move two balls at the other end? Does this only happen in Newton's cradle or also in our daily life? What would happen if a moving car collided with a stop sign, but not all the kinetic energy transfers to the sign? Where do you think the rest of kinetic energy goes? At the time of collision, you will hear a bang, which resulted from the sound energy. Also, the friction of the car with the sign will generate thermal energy or heat energy, and they are forms of the kinetic energy. That means that the car kinetic energy didn't all disappear in the collision, but instead it transformed into different forms of energy. So like the car and the stop sign collision, some amount of the kinetic energy the ball have transforms into different forms of energy, like sound energy that you hear when the balls are colliding, or the generated heat from the friction between the balls, as well as the air resistance as they pass through the air. Some of the energy is lost as sound energy and as friction between the strings and other parts. At the end, as the kinetic energy continues its transfer between the balls, while it transforms into different forms of energy, the cradle reaches a point, then it stops moving, because the balls loses all their kinetic energy, but the energy doesn't disappear or lost. The amount of energy before collision equals the amount of energy generated after collision. Any moving object has kinetic energy, and the amount of kinetic energy depends on the object's mass and speed. That's why when we move two balls, so we have two kinetic energy of two balls, ball 1 and ball 2. So two balls with two kinetic energy will move from the other side. If you leave the moving balls of Newton's cradle long enough, their kinetic energy decreases gradually until they stop after lots of collisions. Energy is conserved during collision, so it cannot be destroyed, but the amount of energy before the collision is equal to the amount of energy after collision.